Bismillahirrahmanirrahim. Now I will talk about alkanes. Alkanes. This is what you have learned about the alkanes so far. Number one, the alkanes are the simplest family of organic compounds. The alkanes are the simplest family of organic compound. Two, they are hydrocarbon. Why? Why we call alkanes are hydrocarbon? Because alkanes contain only carbon and hydrogen, nothing else. Carbon and hydrogen. For example, methane, CH4 consists of one carbon atom and four hydrogen atom connected together, so this is hydrocarbon. Hydrocarbon means contain only carbon and hydrogen. The third, their carbon-carbon bonds are single bond, not double, not triple, single bond. Finally, they form homologous series with general formula CnH2n plus 2. Many questions about the general formula of alkanes, so focus on it. General formula of alkane is CnH2n plus 2. CnH2n plus 2. This is the first one. So we need from here to know general formula of alkane is CnH2n plus 2, and the bond between carbon and hydrogen in alkanes, the bonds are single bond. Here, for example, in methane you can see single bond between carbon and hydrogen, single bonds. Also in ethane, single bonds. Here, single bond. Butane, single bond. Here I have the first four alkanes in organic chemistry: methane, ethane, propane, butane. You can notice here, for example, meth. At the beginning of the name of this compound, we have METH, meth. This means one carbon atom. Meth, one carbon atom. Ane, ANE, this means the bond between carbon and hydrogen is a single bond. So I can understand from the name of this compound, from meth we have one carbon atom, and from ane we have single bonds. Here in ethane, eth, two carbon atom. Ane, this means single bonds. Prop, three carbon atom. Ane, this means single bonds. And in butane also, but, four carbon atom. ANE, this means single bond. Here, structural formula of alkane. If you need to write structural formula of alkane, you will put here C, one carbon atom. How many hydrogen? Four hydrogen atom connected to carbon atom. But remember, in general, there must be four carbon atom connected to carbon. Four hydrogen or four bond must be connected to carbon. Okay. So if you put here double bond, it's correct. Double bond here, two double, 1, 2. Imagine 1, 2, 3, 4, 5. No, not allowed to draw 5 bond. surrounded by carbon atom. In ethane, I have 2 carbon atom and 6 hydrogen atom. In propane, 3 carbon atom and 8 hydrogen atom. 1, 2, 3, 4, 5, 6, 7, 8. In butane also you can see 4 carbon atom and 10 hydrogen atom. Look here, number of carbon atom in the chain. In meth, I said 1 carbon atom. Eth mean 2 carbon atom. 2 carbon atom. Prop, 3 carbon atom. But, 4 carbon atom. Boiling point. Boiling point increase with the chain length. Increase. Look. What about the length of the chain here? Compare it with the length of the chain in ethane. Boiling point of methane negative 164. In ethane negative 87. In propane negative 42. Okay, here negative 0.5. So boiling point increase with chain length. So in general, I need from you to focus on the general formula of alkane, CnH2n plus 2. Alkanes are hydrocarbon because they contain only carbon and hydrogen. Look here. What are the elements you have here? In methane or ethane or propane or butane, you have only carbon and hydrogen, carbon and hydrogen, carbon and hydrogen, carbon and hydrogen. So alkanes are hydrocarbon. Why? Because they contain only carbon and hydrogen. Short me here, carbon and hydrogen alone. Key points about the alkenes. Key points. Now I will talk about 1, 2, 3, 4, 5, 6, 7, 8. Okay, about 8 points in alkenes we need to know. Number 1, they are found in petroleum and natural gas. They are found in petroleum and natural gas. So the source of alkanes is petroleum and natural gas. 2. The first 4 alkanes are gases at room temperature. These are the first 4 alkanes. The first 4 alkanes: methane, ethane, propane, butane. All these compounds are gases at room temperature. He said that here. The first 4 alkanes are gases at room temperature. What is the meaning of first 4 alkanes? We mentioned 4: methane, ethane, propane, and butane. The next 12 are liquid. The rest are solid. So the first 4 alkanes are gases. Next 12 are liquid. The rest are solid. Boiling point increase with the chain length. Why? Because attraction between the molecules increase, so it takes more energy to spread them. Look here, boiling point. What do you notice here? By increasing chain length, the boiling point increase. Yes, increase. Negative 87 bigger than negative 164. Negative 42 bigger than negative 87. So boiling point increase. Why boiling point increase? Because attraction between the molecules increase. So it takes more energy to spread them. The attraction here higher than attraction in methane. Attraction between carbon and hydrogen and another molecules of butane higher than attraction of propane. Called saturated compound. Alkanes are saturated compound. Why? Alkanes are saturated compound because the bonds between carbon and hydrogen are single bond. So called saturated. 4. Generally, the alkanes are quite unreactive. This means they do not participate in many chemical reaction in regular condition or in normal condition. Are quite unreactive. Why unreactive? Because the bond between carbon and hydrogen, or because the bonds which exist in alkanes are single bond. So it's a saturated compound, unreactive compound. Okay. Here we have an equation. We need to memorize it and we understand it first. Used as fuel. Why? Alkanes like methane, ethane, butane, or propane used as fuels. Why? It reacts with oxygen and giving out plenty of heat. Look here. Reaction between methane, CH4 plus 2O2. What's the product? CO2, carbon dioxide plus 2H2O plus heat energy. So alkanes used as fuel because it reacts with oxygen and giving out plenty of heat. Give me scientific reason. Alkanes used as a fuel. This is a question for you. Oh, alkanes used as a fuel because alkanes react with oxygen and giving out plenty of heat energy. Write the chemical equation between methane and oxygen. Here the equation we have. Okay. Six. If there is not enough oxygen, the alkanes undergo incomplete combustion reaction. Combustion, if you remember, combustion is the reaction of compound with oxygen, burning reaction. So we see here incomplete combustion reaction, giving poisonous carbon monoxide. So if you have 2CH4 plus 3O2, both are gases, what does it mean? Sometimes we have a question about these letters exist in a bracket beside element in chemical equation. G, this means gases. L, what does it mean? Liquid. So here 2CH4 plus 3O2 give you 2CO, carbon monoxide. So this is poisonous carbon monoxide, poisonous gas, plus 4H2O liquid plus this heat energy. So we have two chemical reaction for methane with oxygen. Enough amount of oxygen give you heat energy, plenty of heat. And the second is reaction with less amount of oxygen, so the product is less heat energy and carbon monoxide, the poisonous gas. So you should memorize the equation here. CH4, 2CH4 plus 3O2 give you 2CO plus 4H2O plus this heat energy. Look here. If you have enough amount of oxygen, 2H2O. Not enough amount of oxygen, 4H2O. Here, enough amount of oxygen, CO2. But if you have not enough amount of oxygen or this amount of oxygen, you have 2CO. But here it was CO2. Okay. So I have two chemical reaction for methane with oxygen. Reaction between methane and oxygen, high amount of oxygen. This is the chemical equation. And reaction between methane and this amount of oxygen or not enough amount of oxygen. 7. React with chlorine in the presence of sunlight. Here I have what? What is this? methane. Why meth? Because I have one carbon atom, and because the bonds are single bond plus Cl2. The presence of sunlight, one of hydrogen atom which connected to carbon will move away and replaced by chlorine. Cl will come here, so it will give you chloromethane plus HCl. But the question, the reaction must be in the presence of sunlight. Why? Why the reaction must be in the presence of sunlight? Because sunlight help us to break down the bond between chlorine molecule, because Cl2, this means Cl bond Cl, so it break the bond between chlorine molecule. The reaction is called substitution reaction. Why? I said it. Huh. What do you think? This reaction is called substitution reaction. Reaction between methane and chlorine is called substitution reaction. Reaction between methane and chlorine is called substitution reaction because chlorine atom takes the place of hydrogen atom. Look, chlorine takes the place of hydrogen. It was H here before, look, it was H, but now Cl. So this is substitution reaction. The reaction can be explosive in the sunlight, but it will not take place in the dark because it's a photochemical reaction. That means light energy breaks the bond in chlorine molecule to start the reaction off. Cl2, this means Cl bond Cl. Light energy will break the bond, and one of chlorine will take place of hydrogen. Isomers, finally, we'll talk about isomers. I talked about it before. Isomers are compounds with the same formula but different structures. Butane and 2-methylpropane both have the same formula, C4H10. Here C4, 1, 2, 3, 4, H10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In 2-methylpropane, also we have C4, 1, 2, 3, 4, and also H10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Both have the formula C4H10, but structure of butane totally different from structure of 2-methylpropane, and also the chemical and physical properties will be different. For example, boiling point of butane is 0 degrees Celsius, but boiling point of 2-methylpropane is negative 10 degrees Celsius. The more carbon atom in a compound, the more isomers it has. There are 75 isomers with the formula C10H22, for example. Since isomers have different structures, they also have slightly different properties. For example, branched isomers have lower boiling point because of here branched isomers. We have a branch here, not straight chain. We have a branch up here. Branched isomers, like 2-methylpropane, branched isomers have lower boiling point. Yes, boiling point in case of 2-methylpropane is negative 10 degrees Celsius, but in butane is 0 degrees Celsius. Branched isomers have lower boiling points because the branches make it harder for the molecule to get close. Okay? So the attraction between them is less strong, and less heat is needed to overcome it. Again, what do you notice here? Number one, first of all, let me to ask you a question. Here you have butane, and here 2-methylpropane. Both have the formula C4H10, C4H10. But structure of butane, look, straight line. But here in 2-methylpropane is another structure. We have branches here. One branch up. This branch. We notice here the boiling point is 0 degrees Celsius, but here the boiling point is negative 10 degrees Celsius. So the boiling point in 2-methylpropane less than boiling point in 0 degrees Celsius, because negative 10 is less than 0 degrees Celsius. Why? What is the reason? Because the branches, this branch here, I have one branch, because the branches make it harder for the molecule to get close. Harder the molecule to get close together. Harder the molecules. So the attraction between them is less strong. If I have here another molecule from 2-methylpropane, it's harder for the second molecule to get closer for this. So the attraction between them is less strong and less heat is needed to overcome it. And this is what you need to know about alkanes. I will give you revision again. Number 1, you must memorize the general formula of alkanes, CnH2n plus 2. And the first four alkanes you have methane, ethane, propane, butane. Here, key points about alkanes. This is the reaction of methane with enough amount of oxygen. Reaction of methane with less amount of oxygen will give you monocarbon dioxide. Here reaction with chlorine must be in the presence of light. Why? I said before, we need light to break down the bond between chlorine molecules, because we have Cl, single bond Cl. We need to break the bond. This reaction is called substitution reaction because chlorine atom takes the place of hydrogen atom. Here the reaction between methane and chlorine. May you have a question to complete the chemical reaction or choose a product. Whatever the question, you must know the reaction between methane and chlorine form chloromethane plus HCl, hydrochloric acid. Finally, isomers are compound with the same formula, like for example, C4H10 compounds with the same formula but with different structure and different properties, chemical and physical properties. Here, boiling point in butane, compare boiling point of butane and boiling point of 2-methylpropane. Totally different. Here 0 degrees Celsius, but here negative 10 degrees Celsius. Why boiling point here less than boiling point in butane? Branched isomers like 2-methylpropane have lower boiling points because the branches make it harder for the molecules to get close. So the attraction between them is less strong and less heat is needed to overcome it. This is what you need to know about alkanes. I think it's very, very easy according to your syllabus. Thank you for listening. Follow our page, and at the end of this session we will solve a question from past paper, classified past paper. Thank you for listening.